Okay, perhaps we can start if you can describe how Gridmatic's AI load optimizer works behind the scenes. I think it uses forecasting and virtual bidding to create what you call found money for large customers. So yeah, just give us the overview on that.
Yeah, so with the AI load optimizer, what we're doing is we're deploying this to what we call large flexible loads. So customers that have some amount of ability to shift or curtail their load. So these customers in general are already on index type products because the fact that they can change their usage means that if prices rise or if there's a spike, they will reduce their usage. What we've now introduced to them is this capability to look forward, if you will, in like a crystal ball kind of way over the next 24 hours to make different hedge decisions. So using AI and machine learning, we're basically giving them a better forecast of what will happen in the coming day. And as a result of that, a decision can be made as to whether or not they should purchase or not a hedge for the next day. Now, what this effectively does, though, is that as we roll into the day, the customer can still utilize their ability to change and shift their load and not utilize that hedge. But what that also means is then now they have extra energy that they can sell back into the market at higher prices when the grid really needs it. Right. So then in that way, it becomes found money for the customer and it reduces their overall energy spend.
Okay, and in terms of the AI forecasting, it'd be good to understand how it lets facilities confidently shift or monetize, as you said, load in real time. Particularly, I guess there's volatility around renewables and spot pricing. So yeah, how does it sort of address those concerns?
Yeah, so in markets particularly like Texas, we've seen a large influx of renewables into the marketplace, and what that has done is it's created more intermittency. So therefore more volatility. Sometimes the wind doesn't blow the way we forecast it to do, or the sun doesn't necessarily shine, when it's expected to do so. And as a result of that, grid operators can't just like press a button and have it, deliver more solar output. And therefore, that volatility is something that we, from a AI and machine learning perspective, have a better grip of using predictive forecasting to allow customers to identify those moments of potential risk, but also potential opportunity. So therefore, they can take action, having kind of that foresight into those periods when things become a little bit more dicey for the grid.
Okay, and then turning to the Electricity Reliability Council of Texas, or ERCOT, I think it's the acronym. They've
Mhm.
got a dynamic market, and how can data center customers leverage their flexibility to improve when it comes to economics and obviously resiliency is also important, I guess.
Yeah, so ERCOT probably has the most transparent and competitive market in the United States. There are pricing signals that are sent on an interval basis based upon the conditions in the marketplace, and as a result of that, customers have the ability, particularly large customers, have the ability to participate in a variety of revenue streams that help the market and help ERCOT to keep the grid in balance. And so those things can obviously be related to just the raw energy and usage of the energy, but there are other additional kind of ancillary services that large customers can participate in as well. And a lot of this also kind of brings in this aspect of risk and risk management. So you obviously don't want to participate in things that could be overly risky for the business. And so again, utilizing AI and machine learning, we're identifying those opportunities that marry with the risk reward framework of customers so that they can take advantage of those things that make sense for their business, for the risk level that they can tolerate.
Okay, and perhaps just following up on that, it'd be good to understand how participation in programs, which I think you just referenced there, but specific ones are like day ahead market trading or the emergency response service. How can they sort of strengthen grid reliability, whilst also benefiting energy users from a financial point of view?
Yeah, so things like day ahead energy and like emergency response or other ancillary services are a way of creating predictability on the grid. So customers, if they or resources as we would consider them, can purchase or sell into the day ahead market, which gives the grid again like some idea of what to expect. And similarly, the ancillary services bidding into the ancillary service market gives the grid the ability to call on that resource in the need of some type of emergency. So both of those kind of systems, if you will, are available for customers, and by utilizing them at the right times and relative to the appropriate risk reward framework for that customer, it creates additional revenue streams while at the same time offers more flexibility for the grid.
Okay, in a specific example, I think you achieved 5% energy cost reduction for a Texas data center. Perhaps you can sort of unpack the levers that made that saving possible.
Yeah, for sure. So this is related to our recently released AI load optimizer. So what we have found is that by giving customers the ability to identify, once again, those opportunities or risks to hedge in the day-ahead market, they are now able to take advantage of this, and it creates more revenue streams for them that they normally would not have had. And ultimately reduces the cost to them. And it's all being done, again, utilizing machine learning and AI in an automated fashion. So once we set it all up for the customers, it kind of does its thing. We keep obviously an eye on it going forward. We're always looking to improve our tools and optimize our models, but set up and basically, again, found money for the customer.
Okay, and in terms of the sort of performance benchmarks or outcomes that your AI models have achieved back to ERCOT, I think it'd just be good to understand, what is there, what's going on in terms of the benchmarks.
Yeah, so I think we like to think about them in terms of outcomes. So currently we utilize, our core competency here around AI and machine learning in several different ways. The first is in energy trading, so making decisions on when to buy and sell in the marketplace. And so as a result of utilizing kind of our capabilities here, we are the #1 most profitable day-ahead trader in Texas. We also utilize this capability as it relates to battery storage optimization. So we help battery storage to decide when to charge, when to discharge, when to participate in other ancillary services. And as a result of that work, we consistently rank among the top battery optimizers, both in Texas and in California. And as we had talked about, the AI load optimizer, so we apply the same technology for our end use customers, and it allows us to create new and differentiated products like the AI optimizer, which again has created new revenue streams for customers, reducing their energy usage. And we're finding that can be up to about 5% of energy costs.
And then I think there's another real world example. You had a partnership with EdgeConneX in Houston, and that demonstrated time matched carbon free energy. Be good to understand, I guess, how does hourly tracking differ from traditional renewable energy credits? And were there any particular sort of insights that it provided?
Yeah, so traditionally, when customers are buying renewable energy credits, they normally buy them for amounts across a certain time frame. So, for example, if you had a data center that had a 50 megawatt demand, you would go out and purchase, the equivalent of 50 megawatts worth of renewable energy credits across, say, a year. But that may not exactly match when the data center was actually utilizing energy. So imagine if the renewable energy credits came from a solar facility. Well, that would only be for daytime. It wouldn't really match with the nighttime usage of the data center. So what we have done with what we call the 24/7 carbon-free energy product is we are matching the resource with when the customer utilizes their energy on an hourly basis. So therefore, there's more transparency and trust as it relates to actually meeting ESG goals, because you can track exactly what's happening on an hourly basis to understand that the renewable energy that is being purchased on behalf of the customer is matching what they're actually using on an hourly basis.
Okay, and from that, maybe sort of extending that in terms of time match clean energy sourcing, is it possible, or can you see how it can become scalable for other data center operators, particularly as you referenced there, they're pursuing these ESG goals. So what do you see as achievable in that space?
Yeah, absolutely achievable and scalable. I think that underpinning a lot of this is large amounts of data and processing, all of which AI allows us to do, and therefore kind of bringing the pieces together in reasonable and cost-efficient ways on behalf of customers. I think also a key element for making this scalable is products in the marketplace that allow for purchasing of additional hourly type of renewables. So we were really encouraged by recent announcements by the GC Trading Alliance and ICE that allowed for their new granular certificates, which we think that going forward will really be key to enabling further scalability of this type of product.
And in terms of the legislation and policy changes, I'm thinking, I think there's Senate Bill 6 and
Mm.
real-time co-optimization plus batteries, or RTC plus B. What do you think the future looks like in terms of large flexible loads within ERCOT?
I think there's a lot of changes happening. So the two things that you mentioned in particular, SB6, Senate Bill 6, is really about making sure that the grid has a good point of view about what is happening with these large loads. So it relates specifically to loads above 75 megawatts, and by and large, it's trying to get a sense of a better understanding of these large forecasts for demand that we're seeing coming in, how much of it will actually translate into something real. And so it's putting some parameters around that, hopefully will speed up some things, in particular those things that come with behind the meter generation as well. So again, like back to like the idea that having more visibility and transparency in terms of what is real. Uh, the real time co optimization with batteries is really more about making sure that the grid continues to be resilient. So by making these changes, what ERCOT is doing is allowing for better optimization of batteries in real time. So there's less financial waste, if you will. I think the modeling that they've shown is that it could potentially reduce overall spend on the grid anywhere between 13 and 19%. So good utilization of resources should help the resiliency of the grid, but also keep costs down for everyone.
Okay, and moving on to one of my favorite topics, I'll be very interested in this. In terms of, say, looking ahead of a few years, 5 years maybe, how do you see AI transforming the way both data centers and grid operators approach demand side participation? I know that the idea has been out there for a while, and people have perhaps been slightly reluctant for different reasons. But what do you think the AI sort of explosion, I guess we call it that, is going to do for when it comes to demand side participation?
Yeah, I think that ultimately, obviously there's a lot of influx that is projected to come from data centers as it relates to AI, but I view AI as potentially also helping to solve that issue as well. So AI, we have seen and shown in our own business, has a great capability of improving the predictive nature of what is to come, particularly in the short term. And so that then helps provide more flexibility and resiliency in terms of having a clearer focus of what will happen in the near term. And as it relates to data centers in particular, I mean, if data centers can build more flexibility into the way that they operate, that all again kind of helps towards building the type of responsiveness that the grid needs in order to again stay resilient and reliable.
And just widening out the discussion before we finish, we've obviously been talking, I guess, mainly around your experience within Texas. Are you able to sort of compare, contrast how data centers and the energy landscape across the US compares with Texas? So just, yeah, so is Texas sort of ahead of the curve, about average? Just yeah, compare and contrast, I guess, Texas versus the rest of the US, if that's possible, please.
Yeah, so I mean, we are located in Texas. I would consider myself a native Texan here. So, having been here since the deregulation of the market, I would say that overall Texas continues to be kind of a magnet for data centers. Mostly because of the market structure and the competitiveness that is available here, and frankly, like we are kind of what I consider like a test bed for experimentation. There's a lot of things that change and change rapidly here. We're a very pro-business type of state. And so, relative to other markets across the United States, Texas, I think, does stand out as very different and also very transparent in terms of the data, real-time data that's provided, which has really kind of helped us as a business from the standpoint of utilizing AI because data is at the core of being able to kind of understand and leverage that capability in order to provide the predictive kind of things that we need to do in order to bring forward commercial outcomes on behalf of ourselves as well as of customers. But again, Texas has all those elements that really kind of differentiate itself from other markets.
Okay, and I guess the question that everybody is perhaps wrestling with, and there are different opinions, but clearly the data center sector across the world, US being no exception, is expanding rapidly as we've discussed because of AI. Are you an optimist or slightly more cautious when it comes to whether data centers can meet the demands of our digital age with AI coming on stream, etc., without any energy or power capacity concerns, or do you worry that the brownouts, blackouts will become a sort of, I won't say a feature of everyday life, but become more frequent and therefore something needs to be done to whether upgrade the infrastructure more? Just your thoughts as to whether or not there's enough resilience out there, if you like, for the data center expansion.
Well, I mean, this is the question of our time in the energy space, right? So I would say that I am optimistic, but also very realistic. A lot has to change in order for things to go smoothly as we go through kind of this change in the world. And so, not the least of which will be changes on kind of the regulatory side. It needs to be easier, frankly, for both data centers and generation to come online. There needs to be the appropriate kind of incentives for us to continue to grow our generation to meet the growing needs of the demand coming from data centers. And ultimately, I think there needs to be more flexibility in the grid in order to meet this. I'm sure you're aware of kind of the Duke University study from earlier this year that basically showed that if data centers could reduce their availability by just 1%, there would be probably over 100 gigawatts of capacity on the existing grid, right, for data centers. So it just kind of shows you how much we could do even with the existing resources that we had if we had the right amount of flexibility, both from the standpoint of how users, use their energy, but also from the standpoint of resources. So obviously, things like batteries provide a lot of flexibility on the grid, and we believe that the utilization of AI will enable all of those things.
And in terms of what needs to happen, maybe just sort of finally, um, do, who do you see is best placed to make it all happen? Because obviously there are different stakeholders with maybe slightly different objectives. Is it sort of government, whether on a national or state level, that will be driving this and everyone sort of responds? What can the data centers do and what can the energy providers do? Or is it, as I say, down to pretty much the government bodies to sort of work out the policy and then everyone else to join in?
I think it's a little bit of all of it, frankly. So, obviously we need the right kind of policies in place, but clearly private market is moving forward and ahead with also making changes. I think it was just this week that I think it was Emerald AI released a press release that one of the kind of NVIDIA related companies about setting up data centers that have more flexibility. So again, like this idea of flexibility across the grid will really kind of enable the growing demand to really come into the market to, also not disrupt it. And as you say, not create kind of this potential future of brownouts and blackouts that no one wants.
Yeah, it's been great to chat, and thank you so much for sharing so many great insights into what's obviously a sort of complex, fast-moving landscape when it comes to data centers and energy. And as you say, everyone I think is intrigued to see how it'll play out. But it's been great to chat. So really appreciate your time. Thank you.
Thank you, Phil.